Hi everyone. Let's take a look at this brief web-based demonstration where we will compute the future value of an unequal stream of payments. One thing I want to do is format this and make this centered. Okay. The problem appears in the light green-gray color in front of you. $300 is received at the beginning of year 1, $500 is received at the beginning of year 2, and $600 is received at the beginning of year 3. If all of these amounts are deposited in an investment account that is expected to earn an 11% rate, what will be their combined value at the end of year 5? And you are to assume that after the third year, there will be no other payments received. Okay? So here's how I'd lay this out. The beginning of the year, so we know where we stand. Okay, so I'm just going to drop down some numbers here. You can see me entering this, right? Okay. What's the dollar amounts? It is 300 at the beginning of year 1 and 500 at the beginning of year 2 and $600 at the beginning of year 3. And there's nothing in 4 and 5. We could put zeros in or leave them blank. Okay, and let me put a dollar amount on this so we know that this column represents dollars. Okay, we'll format this so it lines up correctly. Okay, well, to compute the future value, we need to know how many years do we have to consider the compounding. And in this case, since there's no quarterly or semi-annual compounding indicated, we assume that when it says, and it's an 11% rate, that is an annual rate, and there is no compounding other than on an annual basis. So what that means is the years represent the periods in this problem, and we have 5 years until the end of year 5 for that first payment at the beginning of year 1, and then 4, and then 3, right? Now you could put 2 and 1 here, but it's really irrelevant for the last 2 years. Okay, so then we need to calculate the future value, and you can do that using the formula for the future value of a single lump sum payment and do it line by line, or you can use the future value of an interest factor. You would use 12% and 5 for this first payment, and the second one you would use the 12% and 4, and you would get that from the table that indicates future value of a lump sum amount. Now, I prefer to use Excel, so I will use the future value formula. And why don't I click this so you can see that I get a nice drop-down list that will tell me where to put things. Okay, so it wants to know where the rate is. The rate appears in this cell. I'm going to hit F4 to lock that in so that doesn't change. It always will be that 12% rate. The next thing it asks me is the number of periods, and that's going to come from that cell right there. Then it will say, what's the payment amount? There is no payment amount. In this case, we are simply determining the future value of a present value amount. And the present value amount is the $300 received. Okay, so once we have that, we are able to compute the future value of that amount. Now, we would do the exact same technique to solve all of these. Now, since Excel uses relevant cell referencing unless you give it absolute referencing, okay, and the dollar sign means absolute. So dollar sign $C16 means for the first term, which is the rate, always use the value in C16. The other ones will move as I copy. Okay, so if I just copy this down, now we only need to go to here, but I'll go to here just to show you that it has no effect. We get the next formula, and you'll see that it grabs the correct parameters it needs. It still references the rate, and since we use the dollar sign, it locks it in. We do the multiplication. We're able to compute that. And then all we need to do is come up with the sign. Okay, now I'm going to do this in 2 steps, or excuse me, come up with the sum of all of those future values. So to answer this problem, let me stretch this a little bit. Okay, we get a negative $2,000. Now, why is that? It's because we assumed in these cases that all of these were amounts received. The way Excel works is it assumes that if the amounts, it's calculating cash flows in and cash flows out. So if these are if you've listed these as cash flows coming in, then this one will tell you how much cash flow going out will equal the future value of those amounts. So the way to really present this problem is simply to flip the sign if you're going to use Excel. So I'll make this a minus sum. And that is the answer. The future value at the end of year 5 is equal to the sum of the future values that we calculated above independently. Okay? And that takes care of this demo. Let me just go over one other item again. I went over this one in some amount of detail. And this one, what I want to point out is, if you didn't want to use the Excel formula, you could simply look in the tables for the future value of a lump sum amount and look for the number where the number of periods would be equal to 4, appearing in cell C11, and the interest rate would be 12%. And then you would multiply that interest rate factor by that $500 amount, and you should come up with the $786.76. To use the tables on the cell in E12, it's the exact same approach. Let me hit the F2 key. Only now the only thing that changes is that you only have 3 years until we're at the end of year 5, right? The beginning of year 3, we have all of year 3, 4, and 5. Okay, so that's how I solve it in Excel, with some bit of brief explanation of how you would solve this using the interest or discount factors that appear in a table. Thanks, everyone.